Hello students, in the last session we discussed about motion parameters, distance, displacement and also the introduction of the motion in a straight line topic. There we discussed how the distance and displacement will act and what are the conditions are depending on distance and displacement. And next we'll move to speed and as well as velocity. First of all, we'll discuss about speed. Speed is nothing but the distance traveled by the body per unit time. Speed, the distance traveled by the body per unit time. That we can say that simply speed. And speed is a scalar function. Scalar quantities. Speed, scalar quantity means which is only depends on magnitude but not depends on direction. And the unit of speed, if you are observing the SI unit of speed, we are considering meter per second. Meter, distance we are measuring in meter, time we are measuring in seconds, so that's why meter per second. But the another unit of speed, generally we are using kilometer per hour. Kilometer per hour. In case if 1 kilometer per hour, this is not SI unit here, this is another alternative unit, kilometer per hour. So 1 kilometer per hour equal to how many meter per second? Conversion if you are seeing here, 1 kilometer per hour is equal to 1 kilometer, nothing but 1000 meters upon per hour means 3600 seconds. 0, 0, 0, 0 cancel. So then here how much you are getting? 2 5s and 2 18s. So that is equal to 5 by 18 meter per second. Nothing but 1 kilometer per hour is equal to 5 by 18 meter per second. 1 kilometer per hour is equal to 5 by 18 meter per second. So that's a small conversion from kilometer per hour to meter per second. If you are writing 1 meter per second, 1 meter per second is equal to 18 by 5 kilometer per hour. 18 by 5 kilometer per hour. 1 meter per second equal to 18 by 5 kilometer per hour. Very important conversions. Because whenever if they are giving the problem in that cases, if the answer may be in problem is in kilometer per hour but answer is in meter per second, that time you need to convert it. Okay. Let's see here one more. We'll move to, in these cases only, speed we have different types of speed. What are the types of speed? Types of speed. First of all we have uniform speed. Uniform speed. Next, non-uniform speed. Non-uniform speed. And then average speed. Uniform speed, non-uniform speed, average speed and instantaneous speed. So generally these are the types of speed: uniform speed, non-uniform speed, average speed and instantaneous speed. So let's see one we will discuss. First of all, uniform speed. Uniform speed. So whatever the speed, the total speed means all speed different types of speed are having same SI unit. So see here, uniform speed means we can able to say that equal distances traveled. Equal distances traveled by a body in equal intervals of time, equal distances traveled by the body in equal intervals of time is called simply uniform speed. What is the meaning of that? Okay, we'll see one small example. Here I am considering distance and as well as time. So then automatically you are getting speed. So see here. Distance. Here a person travels on a straight road. Means he is moving on a straight road. He's traveled first 5 meters of distance in 1 second of time. 5 meters distance in 1 second of time. Next 5 meters. Again another 1 second. Next 5 meters. Again another 1 second. Next 5 meters. Again 1 second. Next 5 meters 1 second. Means you can observe here he's traveled equal distances in equal intervals of time. Equal distances is traveled in equal intervals of time. Then speed we can say that uniform, nothing but constant, no change. So see here uniform speed. What is the speed here? Speed formula what we are using, distance upon time. In the first 1 second what is the speed of the person? 5 meter per second. In second 1 second also means next also here also 5 meter per second. Next here also 5 meter per second. Here also 5 meter per second. Here also 5 meter per second. Means he is traveled equal distances in equal intervals of time. Equal distances in equal intervals of time. So then the speed is said to be uniform. Examples. Uniform speed. Examples. What are the examples we can able to give? We can able to give the rotation of the planet. Rotation of the planets. Because the planets are rotating with uniform speed only. Best example, the rotation of the earth. How much time is taken by the earth to complete one rotation? Generally, self-rotation 24 hours. Means one day we have 24 hours or every day we have 24 hours? Yes, every day we have 24 hours. The meaning of that, the earth rotates with uniform speed. Uniform speed. Speed of the earth remains constant. It is 1650 kilometers per hour from west to east. The direction of this earth means on the speed of the earth, uniform speed. So that's why every day we have 24 hours. At the same time, hands of the watch. Hands of your watch means in the watch we have minute hand or seconds hand, hours hand. How much time is taken by the seconds hand to complete one rotation? Is 1 minute or 60 seconds. For the next rotation also, yes, 60 seconds only. So which is taking equal intervals of time for one rotation, every rotation which is taking 60, and minutes hand also every rotation which is taking 60 minutes, nothing but 1 hour. In 1 hour, the minutes hand completing one rotation. What about hours hand? Hours hand is completing one rotation in 12 hours. Earth completing one rotation in 24 hours. So here about the motion of the hands. One more thing you can able to give. The motion of hands of watch. Hands of watch or hands in your watch. Hands in your watch. Hands means minutes hand, seconds hand and hours hand. In case if battery is dead, so that watch is comes under, the hands are comes under rest condition, not the example of this. Okay, this is about uniform speed. And next we'll take non-uniform speed. Non-uniform speed. We'll see here. Non-uniform speed. Non-uniform speed. What is non-uniform speed? Non-uniform speed means equal distances traveled by the body in equal intervals of time. Non-uniform speed means simple, unequal distances traveled by the body in equal intervals of time. Unequal distances traveled by the body in equal intervals of time. Unequal distances traveled by the body in equal intervals of time. Unequal distances traveled by the body in equal intervals of time. That's we can say that non-uniform speed. So let's see one example. We'll see here in the non-uniform speed. Same you can consider. A person travels distance, time and speed. So he's traveled first 5 meters or first 2 meters in 1 second. In a straight line, he's traveled first 2 meters in 1 second. Next 3 meters in 1 second. Next 4 meters in 1 second. Next 6 meters in 1 second. And then 5 meters in 1 second. So now here you can observe, is it traveled equal distances? No. 2 meters, 3 meters, 4 meters, 6 meters, 7 means 5 meters. First 2 meters 1 second, next 3 meters 1 second, next 4 meter 1 second, next 6 meter 1 second, next 5 meter again 1 second. So he is traveled, so like that. So then what is the speed? First case, speed, distance, how much? 2 meter per second. Second case, 3 distance upon 3 meter per second. Third case here, 4 meter per second, 6 meter per second and 5 meter per second. 5 meter per second. See here, is traveled unequal distances but in equal intervals of time. Unequal distances in equal intervals of time. That's we can say that simply non-uniform speed. What is the example for non-uniform speed? Non-uniform speed, what we can able to give? Yes, whatever you can give, the vehicles are in the traffic. The vehicles are moving in the road. So generally what happens? The speed decreases, increases, changes. Continuously changes. So that's we can say that non-uniform speed. So we'll discuss about average speed. So just now we discussed about uniform speed and non-uniform speed. Next, average speed. What is average speed? Generally speed we are representing with letter V only because it is a scalar function. V only we are representing. Average speed is equal to the total distance traveled by the body. The total distance traveled by the body in the total interval of time. Total interval of time. So that's we can call as simply average speed. So that means V average is equal to. Before that, what is the total distance? For example, this is the origin, means whatever we are calculating, we are referring a reference point. So this is I am considering the reference point. A particle starts at a distance S1 from the point O, is from the origin, which is starts at a point S1 at a time of t is equal to 0 seconds. T1 is equal to 0 seconds. By the time changing, the particle position is changes. After t seconds, the position of the particle is somewhere here. Now actually what is the distance traveled by the particle? Is it starts from here? No. The particle starts from here, from S1 to S2. Means total distance goes to total distance. We can representing delta S is equal to simply S2 minus S1. Delta S2 is equal to S2 minus S1. And total time is, generally we are taking T2 minus T1. If T1 is 0 or whatever, we have to write like this only. So you can substitute the values also, no problem. Is here, what is your delta S represent? Total distance. And what is delta T represents? Total time. So now V average is equal to, we can represent simply total distance, how much? Delta S upon delta T. So this is simply we can able to give average speed. In case, one more example you can take. If the particle is travel d1 distance in t1 time, is like this. Means it starts from here. First d1 distance in t1 time. Next d2 distance in t2 time. Next d3 distance in t3 time. Now what is the average speed? Here simply we are taking the average speed is equal to total distance. Total distance how much here? Simply d1 plus d2 plus d3 upon t1 plus t2 plus t3. Total distance upon total time. Total distance how much? d1 plus d2 plus d3. Total time how much? t1 plus t2 plus t3. So like that we can able to write the average velocity, and also we can able to represent like this, total distance upon total time. In this average velocity, average speed, we have two types of the average speed. What are those? First, distance average speed. Distance average speed. So they are only mention the distance. They are not mentioning about the time. At the time, how to we can use this expression? Distance average speed. So here the condition is a particle is traveled in a straight line, which traveled first d1 distance with a speed v1. First d1 distance with a speed v1. Next d2 distance with a speed v2. Next d2 distance with a speed v2. So then what about the average speed? What about the average speed? So the average speed is equal to V average is equal to, before that you can see here V average is equal to, what is the formula? Total distance d1 plus d2 upon, time is not mentioned but you have to consider here t1 time, here t2 time. So can you write the value of t1 and t2? What is the value of t1? The value of the t1. For that I am writing v1 is equal to d1 upon t1. That means t1 is equal to simply d1 upon v1. t1 is equal to d1 upon v1. t2 is equal to d2 upon v2. t2 is equal to d2 upon v2. Just put the values of t1 and t2 in this expression. Then you are getting V average is equal to total distance how much? d1 plus d2 upon total time t1 d1 upon v1, t2 d2 upon t2. Means why this equation is named as distance average speed? Are you understood here? Yes, see here. Here there is no time in the final expression. There is no time in the final expression. In the final expression what we have? Only distance and speed. For example, here in case if the distances are same, means if d1 is equal to d2, if it is equal distances, then what is happen? If d1 is equal to d2, then d1 is equal to d2. Then so d1 is equal to d2 is equal to, I am considering a value d. So then V average is equal to d1, that is goes to d1 plus d2, 2d upon here d you can take common, means you are putting d, you are also putting d, I am taking d common, then 1 by v1 plus 1 by v2, so then the value is goes to dd cancel, 2 upon LCM you can take v2 plus v1 upon v1 v2, this v1 v2 you can send here, so then the average speed you are getting 2 v1 v2 upon v1 plus v2. So when if both distances are same, then the average speed is equal to 2 v1 v2 upon v1 plus v2. Same case you can apply this if a particle is traveled. Same one example or one problem you can solve here. A particle is traveled first half distance. How much? First half distance with a speed v1. Second half distance. Second half distance. This is with a speed v2. First half distance with a speed v1 and remaining half distance with a speed v2. Then what about the average speed? What about the average speed? So see here, how much? Equal distance na? S by 2 first half, S by 2 next half. So equal distances, equal first half distance and second half distance. So first d1 distance, next d2 distance. Here you can imagine d1 is equal to s by 2 and d2 also s by 2. The meaning of that is traveled same distance in both different. So then what about the average speed? You can write directly the average speed is equal to 2v1 v2 upon v1 plus v2. Yes or no? Is it possible to write or not? So in case if you are finding any confusion, let's go the problem. Let's go to the explanation. See here, what you can able to write? T1 is equal to D1 upon V1. Right? From here, T1 is equal to D1 upon V1. What is the value of D1? D1 is S by 2. Nothing but simply S by 2V1. T1 value how much? S by 2V1. T2 value how much? S by 2V2. So then put the value in V average. V average is equal to first total distance S by 2 plus S by 2. That is goes to S upon here T1 plus T2. T1 is how much? S by 2 V1. T2 is how much? S by 2 V2. From this formula here, from this formula. So then S by 2 you can take common. If S by 2 is common, then 1 by V1 plus 1 by V2. Actually no need to solve, but just I am explaining. This 2 will goes here to again LCM if you are taking, then you are getting 2 V1 V2 upon V1 plus V2. So this is simply distance average speed. Distance average speed. Distance average speed. So we'll see one more example in distance average speed. Here I am considering the situation like this. A car is moving in a straight line. Car is moving in a straight line. You can write the problem, no problem. So car is moving in a straight line which covers first 1/3 distance. First 1/3 distance with a speed V1. First 1/3 distance with a speed V1. Next 1/3 distance with a speed V2. And the remaining also 1/3 distance with a speed V3. So first 1/3 with a speed V1. Next 1/3 with a speed V2. And next 1/3 with a speed V3. Then what about the average speed of the car? What about the average speed of the car? So let's see. First you can write the average speed formula. Average speed is nothing but total distance. How much? S by 3 plus S by 3 plus S by 3. Is it mentioned time? No. So that's why you can take here T1 seconds, T2 seconds and T3 seconds. So that is equal to T1 plus T2 plus T3. Average speed S by 3, S by 3, S by 3. And T1 plus T2 plus T3. Can you write the value of T1? Yes. T1, before that we can able to write V1 is equal to S by 3 T1. Yes or no? Yes. Distance S by 3 time T1. Then T1 is equal to simply S by 3 V1. T1 is equal to S by 3 V1. And T2 is equal to, similarly, T2 is equal to, you can write S by 3 V2. And T3 is equal to, T2 is equal to S by 3 T2. And sorry, V2. And similarly, T3 is equal to S by 3 V3. So, first second, T1 seconds. Second, T2 seconds. T3 seconds. Please keep the values in this expression. Then what we are getting? The average speed is equal to S by 3, S by 3, S by 3 is nothing but S. S only, yeah? S. And T1, S by 3 V1. T2, S by 3 V2. T3, S by 3 V3. S by 3 V3. You can take common S by 3. Then V average is equal to. So V average is equal to S if you are taking common. And here I am taking S by 3 as common. If S by 3 is common, the remaining 1 by V1 plus 1 by V2 plus 1 by V3. 1 by V1 plus 1 by V2 plus 1 by V3. So you can cancel S and as well as S. And this 3 will goes here. Then V average is equal to 3 upon, take the LCM. What is the LCM of this? V1, V2, V3. V1, V2, V3. And here V1 is there, so that's why you are multiplying with V2, V3. V2, V3. Plus, here V2 is there, so that's why that is V1, V3. V1, V3. Here V3 is there, so that's why V1, V2. V1, V2. So V2, V3 plus V1, V3 plus V1, V2. And this V1, V2, V3 will goes here. Then V average is equal to 3 V1, V2, V3 upon V1, V2 plus V2, V3 plus V3, V1. So this is the average speed when the particle is traveled first 1/3, second 1/3 and third 1/3 distances. So we will move to one more conditions similarly to this. Here the situation is like this. A car is traveled first 1/3 distance with a speed V1. A car travels first 1/3 distance with a speed V1. Next, remaining distance. Remaining means how much distance is remaining? 2/3 is remaining with a speed V2. Then what about the average speed? What about the average speed? So you can apply the same process, but time is going to waste. So that's why here I am giving a shortcut that you can use, that can be helpful to you to solve the problem within the 1 minute, less than 1 minute. See here, how much distance which is traveled? S by 3 with what speed? V1. Next, how much next distance? Remaining distance is how much? 2S by 3 with what speed? V2 speed. First S by 3 with V1. Next 2S by 3 with V2. Very simple. You can don't take S. Simply you can take the coefficient of S. Coefficient of S how much? Here 1 by 3. Here 2 by 3. Very simple. So first of all you can take the product of 3 denominator 3 here and V1 V2. 3 V1 V2 upon cross multiply V1 2 V1 plus V2. 3 V1 V2 upon 2 V1 plus V2. 2 V1 plus V2. You may get doubt. Is it right? You can check. I'm taking one more example here. One more example. What is that? First, s by 2 distance with speed v1. Next s by 2 distance with speed v2. You can check in this s by 2, nothing but 1 by 2 with v1. Next 1 by 2 with v2. So then see here 2 v1 v2. 2 v1 v2 upon v1 into 1 plus v2 into 1. So that is v1 plus v2. v1 plus v2. So this shortcut you can use whatever, not only s by 2, not only s by 3, anything if they are asking, just you can able to solve very easily. This can be help within less than 1 minute, means you can able to solve maximum 30 to 40 seconds of the problem. Let's see some more shortcuts. Here, if the particle is traveled first 1/4 of distance with your speed v1, next 3/4 of distance with your speed v2, then what is the average speed? Simple, you can apply the same formula. 4 v1 v2, denominator into v1 v2 upon cross multiplication. What is the cross multiplication? 3 into v1 plus v2 into 1 v2. That's the average speed there. Next, here 2/5, first 2/5 of distance with a v1 speed, next 3/5 of distance with a v2 speed. Now what is the average speed? Again simple, 5 v1 v2 upon 3 v1 plus 2 v2. 3 v1 plus 2 v2. Next, the next shortcut, 3 by 7th distance with a speed v1 and 4 by 7th distance with a speed v2. Then the average speed is 7 v1 v2 upon 4 v1 plus 3 v2. 4 v1 plus 3 v2. Here 3 by 11th distance with a speed v1, 8 by 11th distance with a speed v2. Then average, again the cross multiplication, and 11 v1 v2 upon 8 v1 plus 3 v2. So here I have just a few examples. You can also create your own questions, because every year in the competitive examination most of the questions are generated question only. So up to now we discussed about our distance, our speed, how we can calculate, and their shortcuts. And we'll move to time average speed. Time average speed. What is this time average speed? Very simple. Whatever we are considering without a distance. Here, a car or a particle is moving in a straight line which travels first t1 time with a speed v1, next t2 time with a speed v2. First t1 time with a speed v1, next t2 time with a speed v2. Then what about the average speed? Once again, a car is moving in a straight line which travels first t1 seconds with a speed v1, next t2 seconds with a speed v2. Then what about the average speed? That's the question. So here you can observe the question. They are not discussing about the distance. Not discussing about the distance. So let's see how we can take that. So here I am taking first t1 time which travel d1 distance. Imagine, means we are considering the situation. Next to t2 time which travels d2 distance. So see here, then generally what is the V average formula? d1 plus d2 upon t1 plus t2, because total distance d1 plus d2, total time t1 plus t2. So let's substitute d1 and d2 values here. Generally v1 is equal to d1 upon t1. Simply d1 is equal to what we can able to write? v1 t1. What we can able to write? v1 t1. Next, v2 is equal to d2 upon t2. Then d2 is equal to simply v2 t2. Just put d1 and d2 values in this expression. Then you can get the V average is equal to d1. How much? v1 t1. Sorry, v1 t1. d2 how much? v2 t2 upon t1 plus t2. t1 plus t2. That means what is the time average speed? Time average speed equation. The V average is equal to v1 t1 plus v2 t2 upon t1 plus t2. This is the equation of time average speed. Time average speed. In case if the particle is traveled, t1 is equal to t2 is equal to t seconds. If means which is tracking equal intervals of time, then see here. First t seconds with the v1 speed, next t seconds with v2 speed. You can also take first half time, second half time also. No problem. So then t v1. So then what about the put t1 t2 is equal to t. Then v average is equal to, you will get v1 into t plus v2 into t upon 2t. You can take t common and cancel. Then v1 plus v2 upon 2. Then v average is equal to v1 plus v2 upon 2. So that is simply we can consider the average speed when which travels equal intervals of time. Very important, equal intervals of time which travel first half distance or first half time with a speed v1, second half time with a speed v2. Then average speed is v1 plus v2 by 2. In case if the question is like this, which travels first t seconds v1 speed, next t seconds v2 speed, next t seconds v3 speed, next t seconds v4 speed, like that. If it is happens, so v3 up to v3, or you can take v4 also, no problem. v4 also you can take. So then what is the average speed? Simply you can take v1 plus v2 plus v3 plus v4 by 4. v4 by 4. How many? If it is n and so on, vn in t seconds, right? So and so on, vn upon n also you can able to take. So that's our extension. But here you can consider v1 speed t seconds, v2 speed t seconds, v3 speed t seconds, v4 speed t seconds. Then average v1 plus v2 plus v3 plus v4 by 4. Like that we can able to take. And here also we can apply a shortcut. So generally the shortcuts for time saving, yeah, for time saving. So see here, same. Car travels first half time I am considering. Half time with a speed v1, next half time with a speed v2. Then what about the average speed? Means equal time interval. Equal time interval means you know the formula already, v1 plus v2 by 2. Now we have to prove by using of this formula. See here, t by 2 or 1 by 2. You can take coefficient 1 by 2 v1 and 1 by 2 v2. 1 by 2 v1 and 1 by 2 v2. Very simple. 1 into v1, 1 into v2. Sorry, not like this. Not like this. Cross multiplication for average distance here. Simply the numerator into this and this. So that is equal to 1 into v1. plus 1 into V2 by 2. 1 into V1 plus 1 into V2 by 2. You may apply the shortcut further also. Means first to t by 3 seconds, next to 2 3 by 3 seconds. So that's we will see. We will see some more shortcut based on time average speed. Here a car travels first to 3 by 3 seconds with a speed V1. Next to 2 3 by 3 seconds with a speed V2. Then what about the average speed? See here, t by 3 means nothing but 1 by 3 V1, 2t by 3, 1 by 3, 2 by 3 V2. Simply 1 into V1, 2 into V2. So that is equal to, again same formula here, 1 into V1, V1 plus 2 into V2 upon 3. That's all. V1 plus 2V2 by 3. If you have any doubts, you can go to the formula also. You are getting same answer. Let's see here. Here, first 1/4 time with a speed V1. Next 3/4 time with a speed V2. Same average. 1 into V1. 3 into V2 by 4. By 4. Denominator we can write directly. Here 2 by 5 V1, 3 by 5 V2. So again, what we can able to write, 2 V1 plus 3 V2 by 5. 2 V1 plus 3 V2 by 5. Next here 1 by 6 V1, 5 by 6 V2. So then the average is V1 plus 5 V2 upon 6. So these are the some shortcuts based on average speed, time average speed and distance average speed. So very important, just you have to practice it properly, then you are the successful person. Next we have instantaneous speed. Instantaneous speed. In the last session we discussed about average speed and distance average speed and as well as time average speed. Next we have instantaneous speed. What is instantaneous speed? Instantaneous speed is nothing but the speed of a particle at a particular instant of time. The speed of a particle at a particular instant of time. Let's see how. So here generally we are representing the V instant is equal to we can take limit delta t tends to 0 delta s by delta t. What is this? Actually, if you remember that delta s by delta t is the average speed. In that average we are going to take a small part, that's instantaneous. So that we can able to write simply ds upon dt. So if you are observing that basic mathematics classes, means in differentiation I just discussed related to the small difference between delta and d. Delta represents the large change, d represents the small change. The representation of the instantaneous we are writing ds upon dt, ds upon dt. So see here one example we will take. Means uniform speed. One example we consider here, 5 meters in 1 second, 2 meters in the next second, 3 meters in the next second, 4 meters in the next second, 5 meters in the next second. So like that, if you consider the situation, what is the average speed if they are asking? Average speed means what we have to take total distance. 5 plus 2 plus 3 plus 4 plus 5, 19. By 1 plus 1 plus 1 plus 1, 5. Means what is the average speed here? Simply 19 by 5 meter per second. In case if I am asking what is the speed of the particle in the second means this is only the second. In the second what is the speed? Only 2 meter per second. In third second what is the average speed? What is the speed? Only 3 meter per second. Fourth second, what is the speed? 4 meter per second. Fifth second, what is the speed? 5 meter per second. And the first second, what is the speed? 5 meter per second. The speed of a particle at a particular interval of time is called instantaneous speed. The speed of a particle at a particular interval of time is called instantaneous speed. And instantaneous speed, average speed, there we can discuss about deeply when we are coming to the instantaneous speed and instantaneous velocity. Instantaneous velocity, in this session only we will get, and there we discuss deeply about that. And now, after the speed, we have the very important velocity. Velocity. What is simply velocity? The velocity is nothing but the displacement traveled, the total displacement traveled by the body per unit time. Displacement traveled by the body per unit time. So, what is the displacement here. Sorry. Displacement. Yes. What is the difference between? What is the difference between distance and displacement? Distance is scalar function. Displacement is vector function. So distance depends on, means speed depends on distance. Velocity depends on displacement. So that's why velocity is a vector function. Velocity which function? Vector. Vector quantity. Velocity is a vector quantity. And what is the unit of that? That unit is simply meter per second, and another unit we are using kilometer per hour only, and we know that 1 kilometer per hour equal to 5/18 meter per second. In the previous session only we discussed about this. So 1 kilometer per hour equal to 5/18 meter per second. And here we have different types of velocities. What are the types of velocity? Let's see. Types of velocity. So the first velocity is uniform velocity. Which velocity? Uniform velocity. And second is non-uniform velocity. Non-uniform velocity. And the third is average velocity. Average velocity. And the fourth one is instantaneous. Instantaneous velocity. Instantaneous velocity. Uniform velocity, non-uniform velocity, average velocity, and instantaneous velocity. These are the four types of velocity. Let's see one by one. What is uniform velocity? First, uniform velocity. Uniform velocity means very simple here. Uniform speed, what we gave the definition? Equal distance traveled by the body in equal intervals of time. Here, uniform velocity means you can use equal displacement traveled by the body. Equal displacements. Equal displacements traveled by the body. By the body in equal intervals of time. Equal intervals of time or equal time. That's you can able to give uniform velocity. Simple, same example you can apply whatever we are taking in that. A car travels first 5 meters displacement, next 2 meters, next 5 meter displacement, next 5 meter displacement. So that means uniform velocity means equal distances, equal displacement by equal intervals of time. See here, car is traveling first 5 meters displacement in 1 second. Next 5 meters displacement in next 1 second. Next 5 meters displacement in 1 second. Or else you can take yesterday's problem, if you remember that. A drunk person is walking 5 meters forward, 3 meters backward, 5 meters forward, 3 meters backward. Actually, what is the net displacement of the person? 2 meters in 8 seconds. And again 5 meters forward, 3 meters backward. 2 meters in 8 seconds. Next 2 meters, 5 meters forward, 3 meters backward. So next 2 meters in 8 seconds. So like this, if he's not falling on the beat, he's continuing that. Then what is the average? What is this uniform speed? Uniform speed is goes to 2 meters per 8 seconds. 2 meter per 8 seconds. 2 meter per 8 seconds means 1 by 4 meter per second. Means he is traveling equal displacements in equal intervals of time. That we can give simply average speed. So for this understanding, you can refer the problem of displacement. A drunkard person is walking 5 meters forward, 3 meters backward. 5 meters forward, 3 meters backward. That problem you can remember. Then you are getting what is the uniform speed here, uniform velocity here, 2 by 4, 2 by 8. Nothing but 1 by 4 meter per second first. Next to 1 by 4 meter per second next interval. Next to 1 by 4 meter per second next interval. Next to 1 by 4 meter per second in the next interval. Like that we can able to take 1 by 4, 1 by 4, 1 by 4, 1 by 4. Next. Non-uniform. Non-uniform means, so what is the example we can able to give the uniform speed? A car is moving uniform velocity. A car is moving in a straight line with constant speed. A car is moving in a straight line with constant speed. That we can able to give the example of uniform velocity. And next, non-uniform velocity. Non-uniform velocity. Non-uniform velocity means very simple here. Uniform means equal displacement traveled by the body in equal intervals of time. Non-uniform means unequal displacement traveled by the body in equal intervals of time. Unequal displacement means whatever. So here take one example. A car travels first 1 meter displacement in 1 second. Next 2 meters displacement in 1 second. Next 4 meters displacement in 1 second. Again 1 meter displacement in 1 second. Means what is happening here? Unequal displacements in equal intervals of time. That you can use non-uniform velocity. Non-uniform velocity. Next we can discuss about average velocity. Average velocity. What is average velocity? The average velocity means the total displacement traveled by the body in the total interval of time. Total displacement or net displacement. See here the average velocity. Velocity, remember we are writing as v bar because which is a vector function. Which is nothing but what we can able to write, total displacement. Total displacement traveled by the body in the total time. Total time. See here, the V average is equal to, we can able to write delta S bar upon delta T. Already I just shown an example for you. A particle starts from a point S1 from the origin, means this is the from it starts in T1 seconds, in T2 seconds, up to T2 seconds. If the particle is going S2, then what is the displacement? The displacement is goes to simply S2 minus S1. Displacement is goes to S2 minus S1. That's only we are representing as delta S. Delta S. And here, once we have to remember about average speed and as well as average velocity also. Here average speed we have to remember. So what is that? So very simple here. If the particle is moving in a straight line, particle is moving in a straight line. Most of the particles in a straight line. In a straight line. So in this condition, the average speed is equal to average velocity. Average speed is equal to average velocity. Average speed is equal to average velocity. When particle is moving in a straight line. In case if the particle is moving in a curved path, whatever curved path, So then what happened? The particle is moving like this. So then what happened? Here average speed should be greater than average velocity, because speed depends on distance, velocity depends on displacement. We know that if the particle is moving in a straight line, distance is equal to displacement. If the particle is moving in a curved path, distance is greater than displacement. Same, if the particle is moving in the curved path, average velocity is greater than, average speed is greater than average velocity. So finally what we can say that the average speed always greater than or is equal to average velocity. The average speed always greater than or is equal to average velocity. In the last condition, means last in the average speed session, we discussed about time average speed and distance average speed. All we are considering in a straight line. Remember, we are considering all are in straight line. That means their average speed and average velocity are same. In case if they are asking the same question about the velocities, the answer is that's only. Whatever we are getting, 2v1 v2 by v1 plus v2 or v1 plus v2 by 2. So in case if it is the straight line, then speed is equal to velocity. And when the speed of the particle becomes 0, when the velocity of the particle becomes 0. Let's see here. If a particle is at rest condition, what happened? The speed is equal to 0 and velocity also 0. Speed 0 and also velocity 0. In case if particle starts from a point and again return to the same point, nothing but initial and final points are same. Initial and final points are coincide. Initial and final points are coincide. Final points coincide means same. Coincide. So then what is happening here? Average speed not becomes 0 because distance is not becomes 0, but average velocity becomes 0 because here displacement is equal to 0. Whenever the final point and initial point are coincide each other, then the displacement 0, then speed average velocity also 0. One more thing, speed depends on path and velocity depends on initial and final point. We'll see one example here based on average speed and average velocity. Here the question is, a car is moving in a straight line which is moving from a point A to point B with a speed or with a velocity v1, and again which reaching to the point A with a velocity or speed v2. Means A to B and then B to A. Then what about the average speed and as well as average velocity? What about the average speed and as well as average velocity? See here, average speed. Average speed you can calculate. See here, A to B how much distance? S distance. B to A also same distance na? How much distance from A to B? Same distance from B to A. So you know that whenever it travels equal distances. Equal distance means what is the average speed formula? Please remember that average speed. When S1 is equal to S2 or D1 is equal to D2, the average speed is simply V1 plus V2, 2V1 plus V2 by V1 plus V2. Please remember, of equal distance. D1 is equal to D2 is equal to, yes, we are considering. So here average speed is equal to 2V1 V2 by V1 plus V2. Then what about the average speed? The average speed is this, average velocity is 0 because displacement is 0. Displacement is 0. If it is continually moving in a straight line, then average speed is equal to average velocity. But what happened? It is again returned to the same point. So that's why average speed is 2v1 v2 by v1 plus v2. Average velocity is 0. Next, here one more condition. See here, a particle is moving in a circular path. of radius r, which completing one rotation in t seconds. How much time? In t seconds. One rotation in t seconds. Then what about the average speed and as well as average velocity? See here, average speed is equal to how much which travel distance. One rotation means distance is equal to 2 pi r. In how much time? T seconds. So then average speed is equal to 2 pi r by t. Distance you know that. So distance how much? 2 pi r. Displacement how much? 0. Displacement 0. So that's why average speed is equal to 2 pi r by t, and average velocity is equal to how much? 0, because which completing total displacement is 0. And one more example you can take. A particle is traveling half distance, means semicircular path in t seconds. Then what is the average speed? Average speed here, distance is equal to pi r, displacement is equal to 2r. So then average speed is equal to simply pi r by t, and average velocity is equal to 2r by t. Average speed pi r by t, average velocity 2r by t. You can also apply for 1/4 and 3/4 also. Then you are getting the value. When the average speed becomes 0, the only possibility when the particle is at rest condition. When the average velocity is 0, two conditions. First, when the particle is at rest, and second condition, when the particle is returned to the initial point. So here, the important problem in the last average speed and as well as average conditions. See here, a car is moving in a straight line or straight road which covers first half distance with a speed v0. First half distance with a speed v0. In the remaining half distance, half time with the v1 speed and half time with v2 speed. Then what is the average speed or average velocity, because it is in a straight line. First of all, try to draw that situation. First half distance, how much? Half distance with a speed v0. In the remaining half distance, remaining how much? Half distance is there. In that, half time with the v1 speed, half time with the v2 speed. Then what about the average speed? Simple. This is the combination of average distance and distance average speed and time average speed combination. See here, first half distance with a speed v0. If you know what is the speed in the second half, then you can able to apply 2v1 v2 by v1 plus v2. But here what they give in this second half, they are giving in the 2 time intervals. So that's why try to get this average. What is this average? This average I am considering v dash. So see here, the car travels, second half I am considering with the v1 speed, with v2 speed the next half. Then what is the average here? The v average is equal to simply v1 plus v2 by 2. V dash value you got now? Yes. Here see here, first half distance v0 speed, next half distance v dash speed. Right or not? Yes. So then v average is equal to simply 2v0 v dash upon v0 plus v dash. Put the value of v dash in the given expression. What is the value of v dash? 2v0 into v dash value, v1 plus v2 by 2 divided by v0 plus v1 plus v2 by 2. Take the LCM of this 2v0. So then how much you are getting? 2v0 of v1 plus v2 by 2 whole divided by 2v0 plus v1 plus v2 by 2. This v0 with 2 will be cancelled. Then what is the average speed finally? The average speed is equal to, simply we can take 2V naught of V1 plus V2 upon 2V naught plus V1 plus V2. So this is the average speed when if it is taking first half distance V0, in the second half distance, first half time V1, second half time V2. What we have to do here, first of all we need to get the what is the speed here. If you know what is the speed in the total second half, then it is easy to calculate. So that's why I'm taking like this.